Good day, ladies and gentlemen. Today we're going to talk about Unit 1, Lesson 4, Equations of Lines. It's going to be very important in our study of pre-calculus and especially in our study of calculus. There are three basic ways to write the equation of non-vertical lines. We'll talk about vertical lines a bit later in this lesson. But the most common and prevalent form of the equation of a line is the slope-intercept form. This is the form that you've studied in algebra and algebra 2. Here, and the form is simply y is equal to mx plus b. Here the slope is m, and the y-coordinate of the y-intercept is b. There is only one slope-intercept form for each line. And recall that the slope, and we're going to use this, we used this in the previous lesson, by the way, the slope is going to be y2 minus y1 over x2 minus x1, which also would equal y1 minus y2 over x1 minus x2. Doesn't matter which point, but if you're going to start with the second coordinate, you have to, of the y, you have to start with the second coordinate of the x when you do your change in y and change of x. Okay? And then the standard form of a line is going to be ax plus by is equal to c, where a, b, and c are all integers, and a is greater than or equal to 1. There are infinite versions of the standard form, and some textbooks, not our textbooks, require that a, the greatest common factor of a, b, c, be 1, but we're just going to make sure that a is positive, a is greater than or equal to 1, and that a, b, and c are all integers. That's going to be our standard form of a line, the way we're going to define it in our textbook. And I'll give you an example of that. This example, say I have 3x plus 2y is equal to 6. That's standard form of a line. And there are different versions of the standard form of a line, so that represents a line. And if I take that line and multiply it by 2, or use the multiplication property equality, and if I multiply this entire line by 2, I would have 6x plus 4y is equal to 12, and those would represent the same line. So there are infinite versions of the standard form of a line, the way that we are going to define it in our book. The most important form of a line is going to be the point slope form. This is what we're going to use most in calculus. And keep in mind, we are in pre-calculus, getting ready to study calculus. And this is going to be different than what most books give the point slope form this way. They go y minus y1 is equal to m times x minus x1. But all we're simply going to do is take this y coordinate and add it to both sides. Hence our version of the point slope form, where the point x sub 1, y sub 1 is the arbitrary point, and x, y are their variables. They're going to be the variables in this equation. This is the version that we will use most often. We will certainly use it when we're writing parallel and perpendicular lines. So let's go to example 1. Example 1 says, write the equation of a line with slope of -4 that contains the point 1 comma 8. And we want the slope-intercept form. So what we're going to do is we're going to start with the point slope form. We're going to start with point slope form. And we're going to end up with slope-intercept form. So if I do the point slope form, it's going to be y is equal to, this is my y sub 1. So this is going to be the point x sub 1, y sub 1. It's the only arbitrary point that we have. And so I'm going to put 8 here for y sub 1 plus the slope. The slope is -4 times x minus x sub 1, and x sub 1 here is 1. So all I'm going to do is some simple algebra and write that in slope-intercept form. I'm going to distribute the -4 first. This is going to be -4x. Negative times -4 times -1 is +1. So that particular line in slope-intercept form is going to be y is equal to -4. Let's write the mx first. plus 9. That's the slope-intercept form of the line with slope of -1, or pardon me, slope of -4 that passes through the point 1, comma 8. And you should have noticed that I made a slight error on this particular problem because -4 times -1 is a positive 1. It is positive 4. And so I have 8 plus 4. This particular y value then is going to be the y-intercept is going to be 12. All right, now I want two standard forms of this particular line. So all I want in standard form, I want to write it's going to be in the form ax plus by is equal to c. Well, it's going to be easy to come up with the first standard form or a standard form. All I'm going to do here is add 4x to both sides. And this is going to be my form. It's going to be 4x plus 1y plus y is equal to 12. That's ax plus by is equal to c. If I want another one, all I need to do, I need a to be, if I go back to my definition, I want a greater than or equal to 1. All I'm going to do is use the multiplication property, and this time I'm going to multiply both sides of this equation by 3. And I will get another standard form. 3 times 4 is 12x, 3 times 1y is 3y, 3 times 12 is 36. So those are two standard forms of the equation of that line. And now the question asks 3 point slope forms of this line. Well, what I'm going to need then is 3 points that line goes through. Well, guess what? I already have one that I started out with, and I will go, my first one is simply going to be y is equal to 8 plus -4 times x minus 1. That's 1 point slope form. And what I need to do is I need to find 2 more points on that line, and I'm going to use this equation right here to find a couple other points on that line. So if I let x equal -1, whoopsie, if I let x equal -1, my y is going to be -4 times -1 plus 12. -4 times -1 is 4, plus 12 is 16. So another point is going to be -1 comma 16. So I can use that in my point slope form, and my second point slope form then is going to be y is equal to 16 plus -4. X minus -1 is x plus 1. So these represent the same line. And if I want to find another point slope form, as the example requires, all I need to do is find the y for another x, and let's let x equal 2. And I'm going to use, this is why the slope-intercept form is really nice, because I have my y as a function of x. Put an x in, and pops a y. So if I put if I put 2 in, then y is going to be equal to -4 times 2 plus 12. -4 times 2 is -8 plus 12 is 4. So y is equal to 4. So that point then is going to be 2 comma 4 on that line. I'm going to put that in my point slope form. Let's write that rascal in green. This is going to be y is equal to 4 plus -4 x minus 2. So I have 3 point slope forms of the line with slope of -4 that goes through the point 1 comma 8. This was my particular example right here. Okay. All righty, on to the next page. Now we're talking about, we're going to define parallel and perpendicular lines. Given line number 1 is equal to m sub 1 x plus b sub 1, and line number 2, m sub 2x plus b sub 2. This is theoretical, abstract, because we don't really know the values of n sub 1, b sub 1. But that's okay. We will make it conceptual here in a moment. So, the definition of parallel lines. These two lines are parallel. Line 1 is parallel to line 2. That's what this notation means there, parallel. Line 1 is parallel to line 2 if and only if They have the same slopes, different y-intercepts. So let's write that down. Same slopes, but different y-intercepts. Okay? And now I got this symbol right here that means perpendicular. Line 1 is perpendicular to line 2. If m sub 1 times n sub 2 are negative 1, if the products of their slope are negative 1, or if their slopes, you've heard your Algebra 1 teachers, are negative reciprocals, are negative reciprocals, reciprocals. And we'll give an example of that, so fear not. So I've got parallel perpendicular lines. Example number 2. Consider this line y equals negative 4 plus negative 4 times x minus 4 given in point slope form. Okay, a lot of negative forms going on here. So keep in mind this line goes through the point 4, negative 4. Here's your x minus x sub 1 and y sub 1 right there, and the slope of negative 4. So this thing has a slope of negative 4. I want to write an equation of lines parallel to this given line that passes through 6, 1. So first of all, I put 6, 1 in that. I know that 6, 1 is not on this line. So I know they're going to have different y-intercepts. I want the point slope form, though, and I want parallel lines. So they're going to have the same slope that goes through. That's going to be my y there, plus negative 4 times x minus 6. So that's the parallel line in point slope form parallel to this line. So this line is parallel to this line right here. They have different slopes and different y-intercepts. You could solve that and you could see that they're going to have different y-intercepts. So now I want the equation of a line that's perpendicular to this line right here through the point 6, 1. Well, first of all, I need to find the perpendicular slope to negative 4. Well, that slope is going to be 1/4, since 1/4 times negative 4 is equal to negative 1. And 1/4 is the negative reciprocal of negative 4. So if I want the point slope form, that line is simply going to be y is equal to 1. That's my y, plus the slope, which is 1/4, times x minus 6. So that's the perpendicular line to this particular line right there. Okay? We have some activities for you to do to refresh your, to help you with that. Now I want the equations of horizontal and vertical lines. And here we're going to look at stickman. If we recall about stickman, and I think stickman was in the previous lesson, but all vertical and horizontal lines are perpendicular by definition. So, and what is a vertical line? A vertical line is defined to be a line that's parallel to the y-axis. So this is your x, this is y. So a vertical line is going to look like this. We're going to do this line, and we'll do vertical lines in green. That's a vertical line. These two lines are parallel. A vertical line, by definition, is parallel to the y-axis, and all vertical lines are perpendicular to the x-axis, and they're also perpendicular to horizontal lines, and by definition, horizontal lines, let's go orange, are parallel to the x-axis. So this is a horizontal line, and this is a vertical line. And we saw by stickman that all horizontal lines are given by the equation y equals b, where b is any real number, and the slope is 0. And vertical lines, the slope is undefined. The equation is x equals a, where a is any real number. Here, stickman is falling into the abyss of infinity, and I would ask you to review that stickman handout. It is very important. All right, so I have this point right here, negative 4, 9. I want to write the horizontal line that passes through the given point and write the vertical line that passes through the given point. So let's come up with an XY coordinate axis. We're going to just do that in black here. And I want the point that goes through -4, 9. Let me do this. Let me change the axes around a little bit. Make it down here. And I want to sketch the point -4, 9. So -4, 9 is going to be -4, 9, about right there. And I want the horizontal line that passes through that. Well, what's a horizontal line going to look like? We're going to do blue. The horizontal line that passes through that point is going to be, that's horizontal. And what's the equation of that line? Y is equal to 9. And if I want the vertical line, this is the horizontal line. And if I want the vertical line, so let's go different color here. Let's go red this time. I want the vertical line. Here's a vertical line, but I want that rascal to pass through this point right there. And what's going to be the equation of that line? You betcha. X equals -4 is the vertical line that passes through that point. Alrighty? So that's going to be Unit 1, Lesson 4. Anytime you can always pause the video, and we're going to assign the activity that's associated with this, and then I will post the answers to this particular activity. But keep in mind, this particular question here where it says lines in standard form, you could have multiple. There's infinitely many standard form lines, only one slope-intercept form, and there's going to be infinitely many correct point-slope form lines. And we're going to do parallel, so you can see this activity. Alrighty, so I will assign this activity. Hopefully you will watch the video. Let's go back here, back to the actual lesson, and we will resume later date. Thank you very much.